Yes, sir.
So we shall start with definitions. I think that's important part of this chapter, because in last
Yeah.
chapter we were aware of all those mathematical calculations. Okay, so this is bit totally different.
Okay, sir.
So here we have to understand the meaning of some basic concepts and some theorems, right?
Yes, sir.
So we have first definition of circle. This chapter comes in under the name circle. So what is circle? A circle is a locus of a point which move in a plane in such a way that its distance from a fixed point is always fixed. Okay, that's the
Yeah.
fixed point. We
Yeah.
keep a fixed point and then take a particular length and then move it around. So this is being called a circle. So if we will watch, the distance from each point is equidistance, right?
Yes, sir.
So how we denote the circle? We denote it as C stand for circle, O stand for this origin, and R stand for the radius.
Okay, sir.
Clear? The
Yes.
fixed point is called the center. This is the center. And the constant distance is called the radius.
Okay, sir.
Clear?
Yes.
So with this basic definition, I forgot to increase the size of this slide.
It's fine.
But if we have a chance to increase it, then why not?
Okay.
Okay, so now we have few terms related. Are you writing it down?
I didn't write it, so I'm writing it and you scroll.
Okay, so you let me know. Okay.
Okay. So I finished.
Okay, so now we have few more. This class is basically on the definition of terminology and some theorems. We'll do one or two short problems. So we already see the what is definition of radius. Okay, so a line segment joining center and a point on the circle is called the radius. Okay, so we always know that the circles are always equal in length.
Mm.
What is perimeter of a circle? Circumference of a circle?
2
This,
pi r.
this may be as written it 2 pi, sorry, pi into d. D is diameter, and this 2r is equal to d, right?
Yeah. Yes.
And r, you may say that it is d by 2. This is all, this is diameter, and the half of this will be. So how many diameter can be drawn for a circle?
Mm. Diameter, there can be many
Yes,
diameters.
of course, it can be many. But see, this will come later. What is chord? A chord of a circle is a line segment joining any 2 points on the circle. So we are dealing with this definition. We will be dealing with this definition. What is chord? The line joining a circle at 2 points, any of the 2 points.
Okay.
So my question is, which one will be the maximum length chord where it will be crossing from? Maximum length chord.
Center.
It will always cross the center. If its length is maximum, so it must have to cross
Cross the
or
center.
pass. Yeah. So you have remember it. No need to note down. We already discussed this. Okay. We already
Okay, sir.
discussed this. What is this? If to this, see, this is chord till here to here is chord, but we have extended it far beyond that. So we called it secant. Okay.
Okay.
A line which intersect a circle at two distance point is called secant of the circle. In given figure, this is this. So I asked you yesterday about tangent. Okay. Remember?
Yeah.
So what is tangent? A line that intersect the circle in exactly one point is called tangent. Can tangent is the definition of tangent? Intersect the circle in exactly one point. Exactly one point.
So, sir, it can be any point.
Yeah, any point. Here,
Uh,
here, any point.
Okay, sir.
But what is difference between tangent and chord?
It is outside the circle. The tangent and chord is in the circle. It's intersecting the inside of the circle as well.
This is exactly the one point. Chord always touch the 2 points.
Yeah.
Got the point?
Yes, sir.
At least two, no, or at least 2 point will be only chord, and I think no more than 2 points as well. Clear?
Yes, sir. Yes.
So let's move on.
Hmm.
What is concentric circle?
Circles which
You know what is
see.
concentric circle from your previous knowledge?
Little bit I remember where like there'll be two circles and there'll be one radius going to both circles and one in the inside. I can't remember fully.
Concentric circle is, there are a number of circles, okay, but the center is common. Okay, the radius must be different. If radius is same, it will be considered as a one circle only. But we see this is a small radius is being drawn on one circle. Okay, and this another one is another circle. So the common is the center. So circle which has the same center and different radii are called concentric circle.
Okay.
What is arc of a circle?
It's a piece of the circumference of the circle.
Very good. And how we denote it? We denote it by, see, this is ACB. So we write it ACB and just put an sign of a circle, a small part of circle. Okay.
Okay.
This term we will be using frequently.
Okay.
So now see the degree measure of an arc. So this is one arc. Okay.
Yeah.
the area included by this two radius is one arc, and the angle is measured by the theta. So this is a small angle or minor angle, and this will be major angle, right?
Yes, sir.
What about the congruent arcs? And its measure we suffix or prefix m, and then we write it as this. Okay.
Okay, sir.
So one question again I asked yesterday, what is the angle at the center of the circle? The degree measure of circle is 360 degree.
Okay.
So congruent arcs. The congruent arcs is the arc is that two arc. See, this is AB and this is CD of a circle are said to be congruent if they have the same degree of measure. If this angle is equal, these
And
two
the
angles are
opposite
equal, so
angle.
it means that the arc length will be equal. This is the
Okay.
important property. One property you should write it down. Done?
So finished.
Okay, so I think we discussed already. Semicircle, a diameter of a circle divides it
Just do
into two
arcs.
arcs, two equal arcs. That's the important key point. Each of these two arcs is called the semicircle. You now got the meaning of semicircle?
Yes, sir.
The degree of measure of semicircle is 180 degree. This is
Okay, sir.
straight angle, so that's why it's 180 degree. Now, this is also very important terminology. We will be using it again and again. Minor and major arc of a circle. Okay, so this is the minor arc and this is the major arc, the upper part.
Okay.
So I think it is also, it will be frequently used. So if you have time, you may note it. Okay.
Okay. So finished.
Okay. Now the point to define the segment. The part of the circular region bounded by the arc and chord. Okay. Including the arc and the chord is called the segment of the circle. See, this is arc length.
Yeah.
Okay, and this is chord. A and B is the chord. So area within these lines will be, if there will be either minor segment or major segment. Okay, so you find that its area is smaller than the other one, so you will say it the minor, otherwise that another will be major. Okay.
Okay, sir.
Another one we will be frequently using it, sector of circle. The region enclosed by arc of a circle and its two bounding radii is called arc. Okay. So arc length, this is the arc length. This is the minor arc and another one is the major arc. Okay.
Okay, sir.
Okay. Now the theorem number 1. What is the theorem number 1?
Two
Uh,
circles.
Sorry.
Nothing, sir. I was just reading.
So did you, you must have encountered this word, okay? This theorem.
Yeah, I went through it. I understood theorem number 1 a bit, but theorem number 2, I got confused.
Okay, so we will come back. So the two circles are congruent if and only if they have equal radii. Okay, if you are drawing two circles of the same radius, you will find the matching properties. Okay,
Mm.
got the point?
Yeah.
That's why it's
Yes.
being called congruent. So this was the second theorem.
Yeah.
Okay, so equal chords of a circle subtends equal angle at the center. The first thing is that chord should be equal. So if this AB and CD are the two chords, right?
Yeah.
This is radius and this is
Yeah.
also the radius. So these all radius should be equal.
Yes, sir.
Okay. And this AB is given to the CD is already said. Okay. So we may say that side of all these triangles, two triangle, na, they are equal. All
Yeah.
sides of these two triangles are equal. So this is side congruence.
Okay.
Okay. Both pair of radius are equal. OA
Yeah.
and OB. OA and OC are equal. Similarly, OB and OD are equal. So there's four pair means two sides of the triangle. And it is given that equal chords. Then equal chords is AB and CD. So
Yes.
all sides are equal. If all
Yes.
sides are equal, so what does it mean? Then corresponding angle should be also equal. If you are drawing two triangles, okay, that's two similar triangle, identical triangle. So we may say no, all sides are equal, then all angles are also equal.
Yeah.
So if all angles are equal, these angles are equal to corresponding this angle and this and this. So we may say this angle will be also equal to this angle.
Yes, sir.
Got the point?
Yes.
So better you write it down, note it down. Actually, these proofs are there in NCERT as well. Right?
Yeah, I saw it in the PDF, the exact same.
Yeah. So if you may I recommend you to note it down
Okay,
because
sir.
we will be using these concepts to solve the problems.
Finished.
Okay. So what was the second theorem?
That equal chords of a circle subtend equal angles at the center.
So what is it opposite? What could be it opposite?
What's
This,
the
what could be the opposite statement?
opposite statement? Uh, Unequal chords of a circle subtend unequal angles at the center.
Of course, that's true. But what was my point to listen was this.
If the angle of two equal and the chord sign. Oh, reversing the. Okay.
It's true.
Yeah, it's true.
So if you want to write down the proof, that's it. It is given already, okay? That AOB is equal to COD. AOB is equal to COD. Then we are taking these two triangles, okay? And we again say that the data AO, OB, OD are equal, okay? And this angle are equal. So we have two sides and included angle, right? So
Yeah,
side condition will give you that two triangles are equal. So CPCT, corresponding part of congruent triangle, right? From
yeah.
there we will get AB is equal to CD.
Okay.
Clear?
Yes, sir.
So write it down. Don't get lazy. We didn't study the triangle, na? The criteria of congruence and something. I remember.
Sir,
We didn't study the criteria for congruence of two triangle or similarity of two triangle.
congruence. No, sir. I don't think so.
Similar
No.
triangles we didn't study. Maybe it might be the part of the syllabus before me, or maybe the later, I don't know. So there are few criteria. So earlier we see that all sides of two triangles are equal, then all sides of two triangles are equal, then corresponding angle will be equal. In this part, we are saying that two sides and the corresponding angles or included angle are equal. Then the parts of other triangles or parts of both triangle will be equal according to corresponding part of congruent triangle. Okay.
Okay.
So if you don't remember the meaning of all this, you may write it down. I have written it for you only.
We learned this SAS and SS congruence last year.
Okay, last year. So
Yeah.
recall it. Now, another theorem is if two arc of a circle are congruent, then the corresponding chords are equal. Now, there is one word arc and another word is chord. So which one is arc and which one is chord?
The chord is it, the AB, the line AB and AC, and the arc is the circumference of AB and circumference of CD.
Okay. So
Yeah.
if two arcs of a circle are congruent to arc, this is arc, okay, then the corresponding chord are equal. Does
Okay.
it make any sense?
It means that if the arcs are equal, then the corresponding chords are also equal.
That's it seems, na, for the given circle.
Yeah.
It seems, na. So what is the condition given? We have given that chord AB is equal to chord CD. This is equal to this. So we have to prove that length of this equal to this. Length of these two are equal. So we have two triangle AO and AOB and COD, right? AOB and COD. We say that the circle corresponding AO and OC are equal, the radar, and this
Yeah,
this
name.
and this included angle is also equal. So again, here's side angle side condition will give you that length AB is equal to CD, right? From the
Yes.
CPCT criteria. CPCT. Clear?
Yes,
Write
sir.
down, at least if you don't want to write down the all, I recommend you to write down the all part. But if you don't, at least you have to remember the theorem. Okay,
Yeah, right.
it should be in your mind always. We used to memorize the statement of theorems in our school days time without much understanding it. Okay,
Okay.
each and
We
every theorem in our school days life, we were forced to remember the all statements. We were having our in our on our tongues. So if you do the same, at least you will understand the meaning, because I'm telling you the meaning as well. So theorem is that much important that you should remember the statements, and these
Mm,
statements will save your effort. When you will do
yeah,
problem, if you remember the theorems, you will apply it quickly. Otherwise, you have to do all these calculations.
yeah, even our teacher does that until we understand it, then she does by hearted, and she'll ask every day.
Yeah. So this is almost, I think, the custom of everywhere and every time.
Yeah.
So remember all these theorems, and at least this is different cases we don't have to go through. I think this is the opposite one. Theorem 4, converse of theorem 5 is
Mm.
theorem 5 is converse of. What was theorem 4? It's just
If
opposite.
arcs are of a circle are equal, then the corresponding chords are equal.
Now, if two chords of a circle are equal, then their corresponding arcs are congruent. Okay. So at least remember the statement. And how we will prove the two chords are equal is given that two chords. Where will be the two chords? This is
Eh,
the
eh,
this is the
D.
one chord and this is the another chord is given. So again,
Yeah.
this radar and this radar are equal. Okay, and this angle we know equal. So from the CPCT, and that
Yes.
arc will be equal,
Yeah.
right?
Yes, sir.
Okay, so move on. These are different cases, but we have to know the conditions, all conditions. What is the sixth theorem? This is again an important theorem. The perpendicular from the center of circle to the chord bisect the chords. Okay, if we draw a perpendicular on a chord, it will bisect it. It is in equal length.
Uh,
Yeah, any confusion?
No, I didn't understand what.
Okay, let me show you. This is a circle. I'm not good at drawing. Actually, drawing on writing pad and drawing on board is totally different. Yeah. So this is a chord.
Yeah.
A and B is a chord. Okay. And this is the center of the circle. If you will draw the a perpendicular over it, says
Yeah.
this is M. So this will now AM will be equal to MB. Got the point?
Yes, sir.
Because this perpendicular will divide the chord in equal length.
Yeah. Okay, understood, sir.
Okay. So how we will do? We have to prove that AL is equal to LB, and we know this is the common side. This is equal. This is again equal. So if equal, we are I make the three lines, and this is angle. So see, this is 90. This is 90. So see, OA equal to OB, and OL is common,
Yeah.
and angle L ALO is equal to BLO. So side and side angle side angle side. Okay. Or side angle side, better than call it it's a right angle side, no? Right angle. So call it right hand side.
Yeah.
Okay. So this is the name it given. When it is 90-degree, we say it
Right
right
hand
hand
side.
side. Okay.
Okay.
So the next one is the reciprocal of converse of it.
So I didn't write the theorem 6. Just can I write it down?
It's visible?
Yeah. I finished, sir.
Okay. So the next will be its opposite. So are you getting the idea how to prove these theorems?
Yes, sir.
So keep in mind, either you take the screenshot if you feel that you don't have much time, but you go and try after this class. Okay. So
Okay.
if you will build the habit of proving the theorems from here only, it will be good for you in class 10th. Okay. And onward. So
Okay.
build on this habit. If you want
Mhm.
to write it down the expression proof statements, you may write it down or take the screenshot.
I already wrote it down, sir.
Okay. So similarly, for the opposite one, you may write down the statement of theorem at least.
So finished.
Okay. The next theorem is equal chords of a circle are equidistant from the center. That's obvious if the chord, this chord has the equal length. So either you can draw how many chords of equal length.
Okay.
You are tired today.
No, sir.
Okay. So this is the chord AB and another one is CD. So if it has equal length, so it is saying that it will be equidistant from the center. That's only possible.
Yeah.
It's possible, na?
Yes, sir.
Because I think we can draw only two equal length chord.
Hmm.
That's clear?
Yes, sir.
Only two. Because AB has the unique length.
Yeah.
So if you want to draw another one, you have to make the unique length as well. So this is the only choice. So
Okay.
now if we will draw a perpendicular on the chord, what it will do? It will distribute it in equal parts, right? Equal
Yeah.
parts. And this is 90 angle. This is common in both. This is
Yeah.
common in both. So in both triangle, we find that the corresponding sides are HS again. So from the CPCT, we will say that this length and this length are equal. Got the point?
Yes, sir.
Okay. So at least write down the statement and try to prove it as well. Write down its proof and generate your own proof for the converse of it.
So finished.
Your energy is getting down.
No, I finished, sir.
Uh, so do this problem and in for the day. I won't give you any hint.
Okay.
So what you will do? What will be your first step? I'm just giving you a hint. Draw a circle. Draw a circle of said radius. Okay.
So the radius is so big, I can't even draw the circle.
That's the problem. This problem is not. So what you do, just take some small number. Okay. 15 centimeter, 13 centimeter.
My compass can't even take 13 centimeters.
So just draw a 5 centimeter radius circle. It is still big, but 5 or 3 centimeter.
Okay.
One 12-inch scale has 15 centimeter, right?
So I have a scale just 30 centimeters.
Means it's 12-inch scale.
Yeah, so
Yeah.
I was able to get 13 centimeter, but my compass is not able to go till
Yes.
13 centimeter.
Yeah. So just do 5 or 2, 3.
I'm doing 3, so is it okay?
Okay. Yeah.
But sir, I can't now get 10 centimeter chord because I
No,
took a small.
no, don't worry. Just draw a circle. Okay, this is the 3 centimeter and draw a chord. No problem. Okay. And then
Anyway, sir,
any length. Okay, that's you may draw a length perpendicular from the center to that, so it is visible.
okay, so I did.
Okay, so the radius say 30 centimeter and the length of one of chord is 10 centimeter. So if you have drawn, say that this radius is 13 centimeter, radius is 30 centimeter, and this is 10 centimeter, right?
Yeah,
The question
yeah,
is find the distance from the chord of the chord from the center. This is the center.
yeah.
You have to find this length. Got the point?
Okay. Yeah.
To proceed further.
So I got I have to measure the distance, right? To
Yes.
this. Yeah, so I got the measurement, but I took this 3 centimeter uh, radius, and my chord, I got it around say 6 centimeters.
Okay. So So the circle where your radius is 3 centimeter, you make it 13. Just write the 1 before the 3.
Okay, and my 6
Okay, the
chord.
6 centimeter chord, just you have written 6 like this, na? Just erase it and like write it 10.
Okay.
Now you forget the original measure of that circle. Okay.
Yeah,
Now
okay.
you put it according to your question. So now the radius will be 13 centimeter and the chord length will be 10 centimeter. That's it.
Yeah,
Now it said that find the distance of chord. You did this.
I'm doing it surveyed.
Okay. So what is the radius of your original circle is 3 centimeter. You forget that. You make that radius 13 centimeter. Write it like that. Okay.
Okay.
Cheat with your calculation. The 3 centimeter is now 13 centimeter. And your 6 centimeter is 10 centimeter. Okay. You got that
Yeah,
figure?
okay.
Now we have to find the distance of chord from the center. So just draw a perpendicular from the center. Okay. Now find the distance. This distance. Find the distance of the distance of chord from the center. So how you will do? You get any idea?
I'm I'm thinking that I can't measure it with my scale like.
No. What I said, just listen me. Listen me again.
Yeah.
You have drawn the circle with
Mm,
the 3 centimeter radius and chord. So suppose this is originally 3 centimeter. So what I will do, I will forget all data and I will rename it as 13 centimeter.
yeah.
We don't have to take the original length. Okay.
Okay.
So suppose it's a prototype circle.
Yeah.
That's the point. Whose radius
Mm,
is 13 centimeter and chord is 10 centimeter like this. Okay. Is
yeah.
is totally okay?
Yeah.
Okay. Now we have to find the distance of the chord from the center. This is O is the center and this is the length. Okay. So we have to
It's
find this distance.
it's 5 centimeter.
How you did that? So
Big.
first of first thing, if we'll draw a perpendicular to the chord, okay, say this is M. So how this chord will be behaving now? If it's 10 centimeter the entire length, so tell me,
Divided it,
so what will be this length from here to here?
it'll be 5.
5, right?
And
So
the
what
other
is,
one,
so now it's 90-degree angle. So we may use Pythagorean theorem. So OM will be how much? OM will be,
maybe
OM
for,
square will be 13 square minus 5 square, right?
yeah.
So you did this?
No,
You
I'm
did it
doing.
this way? You did,
I was doing it. So
you was just thinking, but you said it's 5.
yeah, I was just thinking mentally and all that. Like, I
So
couldn't understand.
unless until you won't use your weapon, that is pen, how will you do the hunting?
I was confused because of the 3
No problem.
centimeter. I was getting
No problem.
confused.
Yeah, of course. That's suppose that is prototype circle, okay? And
Yeah.
just rename according to the problem.
Yeah. Okay. The 16 centimeter.
18 or
16,
216.
16,
Yes.
16.
Yes. So a plus b into a square minus b square is a plus b into a minus b. So a plus b will be 13 plus 5.
Yeah.
I'm writing over here. Okay. So and then another will be 13 minus 5.
Yeah.
So it's 18 or
Mm,
2. How much it is?
uh, uh, 36.
36. So this is a
Yeah.
squared. This OM will be over the root 36. So how much you get?
16. No, 6. 16.
How is 6 into 6 is 36.
1, 2, 18.
You did the calculation?
Yeah, but I did just my 13 minus 5, which is 8. So 8 into 2, 8 into 8. Oh, I multiplied 8 into 2.
Okay.
8 into
So
8, 64. 64.
64 how? 18 to the 18. Oh,
8 into 8. So I was doing.
see. Are you able to do it, or should I proceed again for you?
No, I understood, sir, but so I minus 13 minus 5, which is 8. So then 8 into 8 is 64.
See, a minus b is what? A square minus b square. A square minus b square is a plus b into a minus b. So it is 13 square minus 5 square, right? So this
Yeah.
is 13 plus 5 and another is 13 minus 5. So 13
Yeah.
plus 5 is 18 and
18 into 2.
2. So we are left with 36. 36. This is OM square is 36, right?
Yeah.
So it will be a square root of 36 and a square root
Eight,
of 36 is
18.
no, you do. How we will find the square root of 36?
Square.
How we will find the square root of 36?
No, what? No. Six.
Okay,
Yeah. Okay. Okay, I got it.
you got it. So I will again send you some questions. Okay, do it
Yeah.
and submit it. Okay, so any
Okay.
confusion anywhere in today's class?
No, sir. Only this question was a bit tricky for me.
Okay, of course, it's what's new to you. So
Yeah.
what about your confusion about your previous study? You studied that PDF and you saying you have some confusions?
About the circles, I was just confused about the theorems. When I read through it, I was confused.
So now it's clear?
Yeah.
Okay, then enjoy the weekend.
You too, sir.